Just put in the consolidated slides and put it in. Actually, at some point, order 10 of them from China. The fake ones are apparently as clear as Europe. Okay, so please close the doors and have a seat. This is the summary meeting of the Think2Think research group. The Think2Think research group meets in a variety of places. We will talk about that in a minute. But we also like to give summaries to the IETF at the IETF meetings. So we are less trying to do new work here today. We have one new talk, but we are more about summarizing what's going on. Now, first of all, I have to put in the clicker. This is an IETF meeting, so the note well applies. And the pink sheets, which are now blue, are circulated, I think. Oh, they will be. We have a note taker. Where's our note taker? Jaime, where are you? Okay, I think Ari will take notes for the first couple of minutes. Do we have a Jabber scribe? Who can do the Jabber scribe? Thank you, Matt. We have a mailing list, and maybe very important, we have a GitHub repository for each meeting of the research group. So if you go to our GitHub account, T2TRG, you will find half a dozen repositories there, and we try to put things in there, but there is also the usual meeting material manager material, so you can get the agenda and the slides there as well. I'm eating this microphone already. Thank you. We will start with a quick status update. Then we will give a quick summary from the Riot Summit, which took place on the weekend leading to the IETF. We will give a summary from the Internet of Things software update workshop. And one of my co-presenters for that is just coming in, Hannes. And where's Stephen? Stephen's not yet here, but I hope he will be. Matthias will talk about the status in the W3C. I think people really have had troubles coming from the last meeting to this one. I'm not seeing Matthias either. And then we will have a quick run through the documents that we are looking at. So there will be 2-minute elevator pitches about those documents. We will have a research talk about secure, decentralized, blockchain-based Internet of Things. And maybe I should use this as an announcement that there will be an ad hoc meeting of a group of people interested in distributed infrastructures after this meeting. And then we will have 10 minutes to talk about future activities. Hannes. Yeah. And
I don't know if there's time to briefly talk about this Open Trust Protocol, which I submitted.
Let's try to get there. So one possibility is that this remote talk goes up in smoke, then you have time or the other possibility might be that we finish other stuff early. So Hannes has prepared a talk to talk about trusted execution environments. So that may come in. Okay, so this is the agenda. Anything we're missing here? Okay, people are still wandering in. Okay, let's quickly recap what this research group is about. It's the thing-to-thing research group because we are interested in an Internet of Things, and we are in a internet research task force that has had an end-to-end research group for a long time that was interested in looking at end-to-end issues, and we are looking into thing-to-thing issues. So low resource nodes and other nodes want to talk to each other over something that looks like the internet. And obviously that's a giant subject, and we are focusing here on issues where we think there might be an opportunity for IETF standardization, or IETF standardization might need to be informed of some research that's going on. So we go from the adaptation layer to the application layer, including the human user. So we are a pretty fresh research group. We were chartered in December 2015 after already having had a couple of meetings. And this year we had a research group meeting in Nice, or actually Sophia Antipoli, that was co-located with W3C. And we actually plan to do another one with W3C in September. We had one in San Jose, co-located with the IAB workshop on semantic interoperability. We met at Buenos Aires with the IETF meeting, and then participated in the software update workshop in Dublin. So this is what we did so far. There are 3 documents that we consider to be research group deliverables. We haven't really adopted them as research group documents or something like that, but the point is we all have agreed we want to work on that. So these will be quickly discussed in the documents section of this meeting, and there are also several other documents that are interesting in that context. And finally, we have a pretty important item on our agenda, which is outreach. And we have talked to organizations like OCF and Bluetooth SIG. And just this weekend, we started talking more to open source people in the Riot project. So this will continue. We are looking at meetings in research venues in 2017, and we are looking at meetings with open source activities. So we just had the Riot Summit, and we might use the EclipseCon in October in southern Germany for another meeting of this kind. So the idea is to get researchers and open source people who are sometimes the same people, but sometimes are different people together and make some progress. And finally, we want to work on benchmarks and reference scenarios, but that is work that still has to start. So this is where we are at the moment. This is a quick summary. And now I would like to talk about 2 specific workshops that have happened. The most recent one was on Friday and Saturday at the Riot Summit here in Berlin. Riot is a research operating system for the Internet of Things. This is really about M-class platforms. ARM has this wonderful terminology with A-class and M-class devices, and I really like it. In particular, I like being on the M-class. If you're a Trekkie, you know what I mean. So they are targeting microcontrollers, small devices with their operating system, but they also are going a little bit further than previous approaches like TinyOS and Contiki that maybe are no longer quite appropriate to the 32-bit platforms that we're using today. So it's a pretty good match to what we are doing in the IETF and the IRTF. And actually, Riot has a pretty good network stack that may not be the world champion in detailed compliance, but it's really something where you can go and do stuff with 6open and CoAP and CBOR and all the components in there. So we thought it would be a good thing to use this summit where about 135 developers and researchers met, to use that as an opportunity to get some discussion going. And the opportunity was half a day that was reserved at the summit for breakout groups. And I'm not sure how big the other breakout group was, but I think our breakout group was pretty big, discussing the web and the Internet of Things design, hacking, and discussions. So we took a number of items and didn't try to do a PowerPoint attack, but we had a short initial impulse statements, and then we went into discussion. So one discussion that maybe fits quite well with our reference scenario discussion is what should be in a starter pack for an IoT developer. So if you buy an Arduino, there's kind of an idea of what kind of software is on there. You install the Arduino development environment, and it's really easy to get an LED to blink. So what is the equivalent of that in the Internet of Things? And we discussed that a little bit, and how a Riot-based environment could provide such a basic setup. And of course, it's very important for us that this is not insecure, but that it actually provides an environment where you immediately learn to do security. So the second item we discussed about is what are the results of the fact that on constrained devices, you often cannot simply use malloc to do your memory management. And it turns out in the discussion with the implementers that that's a real issue, because there's always a tension between open source projects optimizing for constrained devices and wanting to reuse the same implementation both on N-class and A-class devices. So I think that's an interesting issue where we also can look at from an implementation point of view. But the most immediate result of that tension is that it's sometimes hard to maintain an open source project in this space, because you get all these contributions that solve a specific problem, but maybe solve it in a much less resource-aware way than the rest of the code already is. So maintainers in this space have a bit of a problem. And also, if you want to build something like a starter kit, you maybe want to put in things like Wakama, another open source project that unfortunately is not really very optimized for constrained devices. So that's a little bit of the problem that we have been discussing there. And maybe in unison with that, when we discussed CoAP implementations, we found that it's actually good to have very different implementations, very different levels of functionality in implementation. So we have something like micro CoAP, which really is not much more than a protocol decoder, and the rest of the work has to be done by the application. And we have full-fledged implementations like libcoap, and several attempts between these two ends. So people think it's good to have this choice, and of course the next step will be talking about the programming interfaces of these. We also talked a little bit about the cloud side or hub side implementations like AIO CoAP, and we limited a bit that the number of open source resource directory implementations out there currently is still limited. So that's maybe something where we should initiate a push that we get more resource directory out there. We also looked at the area of hypermedia controls and presented a little bit of the W3C Web of Things approach. And maybe one interesting data point is there is a new JavaScript engine called JerryScript that actually is useful, at least in the upper end of the M class. So if you have a megabyte of code and 128 kilobytes of RAM, then you can put this comfortably in your environment. And these chips exist, so they may not be the most power efficient, but for applications where that is maybe less of a concern, that really allows you to work with mobile code. But JavaScript, of course, is not the only mobile code platform. There's also Lua out there, and maybe just generally looking at the role of mobile code on M-class platforms is a quite interesting subject, and it's also probably a good idea to look at the different roles that devices can play, from the simplest temperature sensor that essentially is unaware of its purpose in life, it just sits there and tells people the temperature, to devices that actually actively look around and discover new devices and then try to find out how to communicate with them. We had a short discussion about data formats. We have been discussing SenML in the core working group, and thought it might be good to discuss this with the implementers. They still don't like floating point. I know, Hannes, you have chips with a floating point on it, Cortex M4 and this stuff, but there are other chips as well. So yeah, it's probably worth looking at the role of floating point in formats like SenML. And JSON libraries are a little bit larger than one thinks, because you always link a 4 or 5 kilobyte printf with that to get your data format in decimal. So there's quite a bit of implementation experience with SenML now, and the authors took some feedback with them and can use that for clarifications. Finally, we talked about security. Right now, in the open source space, there are two implementations out there that get a lot of attention. One is the Embed platform that we didn't really talk much about, and the other one is TinyDTLS, an Eclipse project. And generally, there was good feeling among the implementers that using a focused set of cycle suites around PSK can bring them forward, but in the open source world is still pretty chaotic in terms of crypto implementations. So this is probably something where we need a little bit of cleanup. So it's not obvious for an open source developer today what kind of ECC implementation you would use. So yeah, that's something that maybe one or the other chip provider also could help people with.
Yeah, Zach Shelby. So you mentioned Embed. I think you're referring to the Embed TLS Apache 2.0 implementation, which is becoming pretty standard. Set of crypto libraries and TLS and DTLS with DICE support for M class in particular. So yeah, I think we just need to get better at documenting for people what's available and how it can be used.
I think one perception about Mbed is that it's pretty monolithic, and you don't have to take it that way. So
Not at all.
That's where
No.
just a little bit of information that needs to go out there.
Yeah, Mbed TLS is its own implementation completely. And there's tarballs, its own GitHub repository and everything. So you can just take that, use it. But I think it's about educating. We do need to document things like this and educate people where they can get code. It is available. Of course, you can always deal with more embedded implementations of everything.
So there's also an LWIG draft about crypto implementations. Maybe it would be a good idea to make sure that gets the current information in it. Okay, and we had a little bit of discussion about complementing DTLS with object security. And one interesting question is, can we avoid having a lot of different security libraries which are activated at different periods in the lifetime of a device, because that's really a recipe for security problems. If you have something that is not really exercised a lot because you only need it for bootstrapping, that's a problem. Random number generators continue to be a problem. And so for instance, Riot will get an entropy pool implementation to ease that somewhat. But yeah, it would be nice if all chips had this. And finally, we had a discussion about firmware updates. I will get to firmware updates in a minute. So after we have talked for about 5 or 6 hours, we generally felt this was a good meeting. I always ask this question at the end when everybody who thinks it's not a good meeting has gone home, and that usually works, but not that many people had gone home. And we plan to have some form of follow-up there. That's always a little bit hard to organize, but we don't have to do it in form of physical meetings. We can also do some meetups in the virtual space. And we also agreed to pay particular attention that information on the Riot lists and on the IETF, IRTF lists that might be beneficial to the other side actually gets forwarded, and we get people involved in ongoing activities. So that's my summary from the Riot Summit. Anybody who was there who wants to add anything? Can the rioters please stand up? Yeah, I think this is a nice demonstration that it's useful to have this kind of workshop together. Kerry.
Kerry Lynn, just would like to make a comment that it's good to have 30+ days advance notice of these meetings coming up for those of us who have to travel, say, internationally. Second question I have for you is the M class the new class 0 in your opinion?
No.
All right. Just
M class encompasses class 1, class 2, class 3, class 4, and class 5.
Okay. We're not forgetting about the little 8-bit micros, right? They're still going to be around for a while.
The 8-bit micros are not going away, even if some people would like them to go away, but they are.
Hi, Jaime. I was in the Riot OS. I found it particularly useful, really good. The tutorial was excellent, and I'm wondering, basically, I would like to ask other platforms like Mbed or others out there if they have such comprehensive tutorials for starters and beginners, because I think that could be a changing point for many, in my opinion.
Yeah, Zach Shelby from ARM. So yeah, of course, we have a lot of tutorials and things. I would request a little bit, I do find a little bit of strange, if we're connecting the IETF with a particular implementation. We don't do that typically at the IETF. So I would request, if we're going to promote a workshop, let's make it a implementations and plug tests for lots of different implementations of IoT, and not make it something specific. And then, if you want more information on Mbed, please invite us. We didn't know about it, or we weren't invited, so next time let's make it maybe a bigger thing. That'd be really cool.
Thank you.
Hi, Emmanuel Bocelli in Real. So, yeah, I'm totally with Jack here. So we're probably going to do another Riot Summit next year, and we definitely want to expand. So there's probably going to be space for embed, and it's very welcome. And we certainly don't want to go towards like monoculture or anything. We think that's bad. And so that would be great. And I want to thank everybody who was participating in Riot Summit. And yeah, we'll see you next year for something similar and better.
Oliver Hahn. So we also tried to get a meeting with the Contiki people for at least 2 years, but it's really difficult to get a hold on them. So yeah, as Amanda said, it would be really welcome to meet with more developers from more different operating systems or different IoT libraries, but sometimes it's difficult to even find a community for some of these systems. So yeah, that could be a good forum here to organize this.
So having something like the Eclipsicon meeting in October would provide a slightly more neutral place for different open source projects to actually meet. So I think that's a good thing to do, but I also think it's a good thing to go to specific projects and hear what their specific needs are. Any other comments? Then I would like to go to the next item. There was a IAB-sponsored workshop on software updates in Dublin a couple of weeks ago, and the typical problem that we have when we have these workshops, these IAB-sponsored workshops, is that after about 2.5 or 3 years, we have the RFC that summarizes them. And I thought it might be a good idea to actually have a summary a couple of weeks after the meeting. But unfortunately, the only slides I have are slides for my students. So there will be an assignment at the end. Sorry about that. Maybe there's a little bit too much context here, and I will skip over that quickly. So just to remind people of something that we have been discussing in a while, and that is now also in the one of the documents of the research group. We have to think about life cycles of Internet of Things devices, and one very important event in the life cycle of an Internet of Things device is the software update. And there are many questions around that. So it was a good thing to come together and see what experiences do we have, what approaches do we have, and what might be the open questions that need to be addressed. So I'm unable to give a 2-day workshop to really put that together into half an hour, but maybe I can at least point out some things. So we started with an interesting paper that looked at an event that happened in 2003, where a company put out a device, not an Internet of Things device, but a device that had a certain flaw. It actually sent a packet every second to a particular NTP server. And so that device was put out in about 700,000 units. At least we know about 700,000 units, because all these 700,000 units send a packet every second to that NTP server. And it's just an interesting example of what happens in the real world. Well, of course, the population ramps up because the product hits the store shelves and is bought and is installed and so on. And of course, after after a little bit of time, the vendor noticed that they might be liable for the damage they do, and actually did put out a software update. So what happened here is that the population went down. But we don't really know whether the population went down because that software update was installed, or just because Wi-Fi was at an interesting crossroads at the time and people just threw out their old Wi-Fi devices and put in new devices with more security and 802.11n and so on. So after almost 3 years, there was still about half of the population out there, although the vendor had provided a software update. And because the person who did those measurements changed jobs, we don't know about the exact number, but we know that on April 3rd this year, there still were about 3,564 devices out there connected to the internet and sending a packet every second. So this shows that software updates actually need attention. I hope I'm not violating the sensibilities of a certain company here, but this is something that made the news. So there was a software update for a device from one company that does temperature control. Hi, James. And this software update had an interesting bug because it didn't just kill the thermostat. No, it slowly depleted the battery over the course of 14 days. So it's not something that when you roll out this software update, you immediately notice. Yeah, so after a certain amount of time, the thermostats suddenly stop working. And of course, the time when they stopped working was the worst polar vortex that had been in the US for a long time. So this is an example of a software update that might cause consumers to actually be very careful about putting in software updates. In this case, it was pushed by the vendor, but if consumers have control over those software updates, that's a problem. And if you think it's not rocket science to do these things, well, it may be. So there recently was a software update for a Japanese satellite that caused it to spin out of control, and the forces that came up with that spinning caused the satellite to break up. So it's software updates are difficult, and we need to find ways to make them happen and to make the user experience for them acceptable. Okay, so at the workshop we looked at a number of things. So we came up, Hannes came up with this A-class and M-class terminology, which I like. We looked at the existing terminology for constrained devices and why we want to move the boundaries to enable more devices to join the internet. We had a quick discussion about trust zone, which maybe we can pick up later today if we have time. And yeah, so security is not always motivated by pure altruism, but sometimes these devices are designed with security in them because there is some specific asset that needs to be protected. Okay, just to make sure that this was not an ARM event, we did have Intel people here. Let me skip those slides. This workshop was based on position papers, and this is really homework for you that you can take home. Look at some of these position papers because they are really interesting. So for instance, Russ Housley has an RFC out there done in the middle of the last decade that describes a format for software updates. So this is interesting to look at, and he describes some experiences from that. We had a paper about incentives for software updates, which essentially argued there should be something like a quality metric where you can make transparent to consumers whether their devices are being updated or not. Yeah, and there are lots of papers, including this one about the Netgear incident in 2003, and so on. So, yeah, companies often fail to ship software updates. That's one problem that we have here. And the question is, how do we create transparency here? So, of course, there are crash tests with cars, and magazines publish crash tests, so you know which cars are more safe than other cars. And of course, people still buy the unsafe cars. So that may not completely work, but still it may give some incentive to actually do software update. But it may also be important to Gary, you want to say something?
I have a question that's related to this, and maybe relates to the first slide that you put up. At one of the plenaries, maybe in the past 1 year, somebody brought up the concept of you can update, then you should just die after some period of time. And I just wonder if this was something that was discussed at the workshop.
Yeah, the deadman switch of software updates that actually did come up. But of course, there are liability issues around that, so it's not something where you can just assume it will. So the 800-pound gorilla, of course, is the regulator. At some point, regulators are going to step in. So as with Tesla, somebody has to die before regulators become interested. But once that happens, they will step in. So we will see what happens there. They cannot be prepared for that. Okay, but it's probably important to keep in mind that the Internet of Things is composed of very different devices. So there are these jelly bean devices where you buy a lot and put them somewhere and throw some away and so on, which are very different, for instance, from regulated devices, for instance, healthcare devices. I'm not talking about Fitbits here, I'm talking about insulin pumps and something like that. There are devices that have an obvious security impact, where it may be easier to get something like this going. There are devices that have a safety impact, and people have learned that thermostats actually have a safety impact. And more generally, there is a difference between pet devices and kettle devices. So there are lots of devices that you will just throw out and expect to work, but you're not going to provide your attention to these devices. This is the kettle. And then we have pet devices that we actually stroke nicely and so on, that we really like and that we are willing to put some attention in. But most of the Internet of Things will be composed of kettle devices. So the general observation was users don't want upgrades because it works well enough as it is. And I just want to make phone calls. So, there's always a fear that the evil vendor might be deleting some function from the device, and suddenly things that users relied on, including bugs that users relied on, users often rely on bugs, might go away. And that's not theoretical, that has happened a few times already. So that makes users very wary of actually installing upgrades. And as you know from risk perception in general, a single upgrade going wrong is likely to close this window for quite some time. So the question is, how can we motivate users to actually want software upgrades? And also, how can we do software upgrades in a way that makes less use of the cognitive resources of the users, just for this single reason that it's not okay to constantly ask them for something. Now, on the other hand, there are these shiny platforms, and I'm talking about a pet platform here, not a kettle platform, where we have wonderful statistics. 85% of iOS devices run the most recent generation of the platform. So sometimes it is possible. There's somebody on the microphone.
Hey, Karsten, it's Elliot Lear. Just a question. Do you want to take comments now, or you want to?
Yes.
Okay. So if you back up to the previous slide, there was actually a really cool paper that was delivered to the workshop on the economics of information security that looks at that took place in Berkeley in June, right on top of this workshop, by the way. And what they did was look at incentive modeling precisely for software upgrades, primarily for, they were thinking in the context of Windows, but yeah, the basic idea, and I refer to people, if you go to, if you Google a workshop on the economics of information security 2016, you can find the paper. What they did basically says, well, we're going to charge you if you want to choose the timing of your upgrade, right? So it's a software licensing model. We're going to charge you if you want to choose the timing of your upgrade. You can do it. You can choose the timing, but because there is an impact on others, and especially in terms of our own support costs, we being the vendor for some value of vendor and some value of we will, you're going to hand us your credit card when you buy this device, and if you want it to actually work, occasionally we're going to. So I'm not saying that's the right model. I'm just saying that paper exists and people might want to take a look, and it does address this precise point.
Can you send a pointer to the paper, to the list?
Sure.
Thank you. Interesting. Okay, let's quickly run through some of the items here. So what we discussed to some level of detail was the paper 01 that talked about RFC 4108 and its design rationale, and also about another important aspect, which is how do you make sure that your software update is still secure at the time when we finally have quantum computers. So this is something that is addressed in this document, post-quantum security for software updates. So in general, of course I'm stealing slides here. In general, we can look at device requirements, we can look at infrastructure requirements, but we can also look at manufacturing requirements. And I don't have time to go through all of these. This will all be in the summary. But there are quite a few things that you have to keep in mind when you actually do software updates. So there may be a need for multiple entities to actually authorize a particular update. It may not just be the vendor, it may also be somebody else who is a stakeholder and needs to agree that the update has to happen. So one thing we discussed was, can you do partial firmware updates? Of course, in A-class devices, we are installing new software all the time, and we are not necessarily rebooting for that. In M-class devices, we often replace the entire software set, and can we go beyond that even on constrained devices, or even provide hitless upgrades where the upgrade just happens and the user doesn't even notice. On the infrastructure side, of course, the infrastructure has to provide all the things that are needed to get the security that we want, but the infrastructure can also help in actually distributing the updates in a sensible way. So several papers looked at schemes for essentially multicasting or using ICN-like approaches for moving those updates. Now, there weren't that much people there who were talking about manufacturing, but there were quite a few aspects that came up in the discussion there. So, for instance, can you actually have internet access in your factories? So can you do a provisioning scheme that requires the factory to have internet access? Okay, I think I'm already a little bit over my time here. You could, yeah, but I also have more slides. Okay. And the assignment here. Oh, yes. Looking at authentication, of course, the operative question is, can the firmware be trusted? And we usually reduce that question to the question, can the source of the firmware be trusted? But that may not be a trivial reduction. So there may be other things coming into the decision whether the firmware can be trusted for the specific need. And a related question is the firmware really for me? So the source may provide wonderful new firmware for device X, but if I install it on myself, then suddenly something bad happens. So there are things like hardware revisions coming in here. There may be options that are installed or not installed, and so on. So you really have to look at the prerequisites. Do I have everything in there to take an upgrade or not? And finally, there may be something about the usage situation that makes an upgrade desirable or not desirable. We have, as always in authentication, we have a freshness issue. So is the firmware fresh? We may want to avoid downgrade attacks. You can do this by ratcheting up your firmware version, but if you are ratcheting the version up, only allow upgrades, don't allow downgrades, then you suddenly put the user in a position that when they find out the new version has problems with a specific feature that they rely on, they cannot downgrade. So that's a difficult issue. You can also have interesting attacks like weak upgrade attacks. So a user knows they have to put in an upgrade, they do the upgrade, but in the end, the upgrade was weak. It was not actually solving the problem that the user was trying to solve. And you can have these side grade attacks where you get the user to install something that is different. Okay, so at the end, we talked a little bit about future issues. I'm not going to talk much about transport, but it's worth pointing out we have a few solutions. So for instance, Lightweight M2M has a software upgrade mechanism. So it's not like we are on a completely green field here. So things are out there, and we looked at ways how this can be done in a reasonably efficient way. But there's also just a management question. If you have a sea of devices, how do you actually know which of these need updates? How do you know what you have in the first place? That's, by the way, the problem that is not only common in the Internet of Things, but also in enterprise networks, where typically people have no idea whatsoever what's in that network. And so it helps if devices are self-describing. So I think we have been doing something right here with core link format and so on. But the self-description also needs to be trustable in some way. So we are running into all these problems with attestation and secure elements and so on. Yeah, push-pull, usual question, but maybe also interesting question, how can we limit the damage of actually doing an upgrade? So I remember this talk I had to give in front of about 600 people at the time when I was still using a certain operating system that liked to use upgrades. And so when I went to the podium and wanted to give my talk, it actually was installing an operating system update. You don't want that to happen to you. But if you are a young person planning an event with somebody else, maybe you don't want your lighting system to go into an upgrade in the middle of whatever you are doing in that event. So we have to have upgrades that are either hitless, so you can do them without damaging the functionality, or that are postponed to periods where the device is not in a critical operational state. And that's hard, because to probably do that, the device probably needs to know more about your context, your personal situation, than you are willing to tell the device. So there is a little bit of a conflict with privacy. Yeah, and of course we want to be able to identify upgrades that go wrong, do rollbacks, and so on. And possibly in a sea of devices. So if you look at the ceiling of this room, you have an idea how many devices are in this room, and if they were doing a software upgrade right now, that would be a problem. So yeah, we talked about a couple of technologies. I'm not going into in detail. Yeah, even nets are sometimes a problem in this space. And we talked about more formal approaches to actually solving the problems here. So what modeling can we do? For instance, if we have software going into a complex device such as a car, how can we make sure that the software that goes into a car that is probably not the same as any other car, even of the same make and model, how can we make sure that that kind of software will work? And there are some technical approaches here that I'm not going to go into But it was interesting to see that they had dug up RFC 2704 to do some of their work. I don't know who in this room remembers that. Anyway, so to do this properly, we need to understand the components that are in software. So if I have 250 devices at home and I learn about a new implementation bug in TinyDTLS, I need to know which of these devices is using TinyDTLS to understand, is there a problem right now or not? So components are important for finding out what I have, but also for doing hitless upgrades and for maintaining the ecosystem of upgrade sources. So if you have 250 devices at home, you probably need 30 or 40 upgrade sources to get upgrades for all of them. And you may not know who they are. So we probably need some modeling here. And it's actually interesting to see the parallel between the system definition modeling that we need to do this properly and the data modeling that we already have been talking about when we looked at how we can describe the services that a device provides. So there are a lot of parallel issues here, and there may actually be some synergy. So it might be possible to actually get some commonality here, so you don't have to redo every single problem again in a different way for software updates. So I'm going to split these slides here. So components are an interesting question, and there is an implementation problem. How do you run components? But there are also non-technical issues. So what are the license models here? How does a vendor avoid giving away a secret source and so on? But then we do have component-based systems, and this was one slide provided by someone who had a pretty elaborate way of making sure that even a failed software upgrade doesn't leave the device inoperative, but allows continuing with over-the-air upgrade. And these people actually start thinking about continuous deployment. So imagine your thermostat gets new software every hour. That's the kind of situation where we want to be at in maybe a couple of years. Okay, again, I'm going to split, to jump forward here. So the assignment for the students, unfortunately it's in German because this is a German university, is to look around, see what devices do you have that would need software upgrades, and do you even have any idea where you would get them? Or what process might be used for updating them? What about your TV? What about your car? And so on. Okay, questions?
Can we postpone this a day for that?
Yeah, unfortunately the deadline already is gone. I'm sorry about that.
Carsten, thanks again for this discussion. It occurs to me that there are a couple of other interesting dimensions that go beyond. I realize this is a workshop report that you've been giving. There are a couple of other dimensions that one has to look at in terms of software update. So for instance, the criticality of the update itself. If you know you have a bug that you have to get fixed because there's a rampant vulnerability that everybody knows about and they're taking advantage of, then you want to get it out quickly. Whereas if you discover the vulnerability, you don't know if it's out there. You may think it's not out there, in fact, and you have time on your side a little bit to organize the release of vulnerability, or even just an improvement of some form. Suppose you're doing introducing a larger key capability or something in software or some such. The key point is that we now have a lot of experience in terms of software update to know how to implement those sorts of capabilities in the sea, if you will, or with the cattle, if you will, such that you don't do them all at once. This is something that the cable industry learned through hard experience, for instance. And so I do think there's some opportunity to take this work and add a little bit more to it in terms of richness. I don't know how to go about that, but I can see some opportunities there.
Thank you. Hannes, anything you want to add? Or? Thank you. Yeah, so thanks to the program committee and the people who organized this workshop. That was really useful. Next on the agenda, Matthias.
Thank you. Okay, we don't have any pink boxes. Good. So this is an update of the W3C Web of Things activity. So there has been an interest group running for a while already. There's also kind of a joint activity between this T2T research group and the Web of Things interest group. So we had already joint meetings and we plan to have more. So this is basically an update what happened recently. Maybe most interesting for now, the interest group recharters. So we ran out of charter in quite some time ago, I think in March. But we now got a positive AC review of the new working group charter. So 34 companies or AC representatives from different companies are in favor of the new charter. One suggests changes, but basically supports the proposal. To have a quick summary, what's the scope of this interest group charter. So the main point is actually to support the proposed working group. So will be next on the agenda. We want to have the working group that is then actually able to work on standards. So this is something the interest group cannot do. Another point is execute so-called plug tests. So this is an idea to establish the tower of having running code also in the W3C. So we want to develop something that is already working, to prototype and so on, that goes into the decision making, also for the standardization work. And then quite central in the interest group is the collaboration with other SDOs, alliances, communities and so on. Because the interest group is more open than the upcoming or proposed working group. And the last point is this interest group is supposed to be a bit like the research group here we have in the IETF, so to look a bit more in the long-term goals and then have a more researchy touch on the overall work. Then, as I said, we are working on a working group charter. You find the current draft here. The roadmap looks like this. So at the moment, we're integrating feedback from peer-to-peer outreach. So we have been showing this charter around already to some potential interested parties, what they think, so that we kind of have a charter draft that is already in pretty good shape when we present it to the official process. So we are still incorporating feedback. If you are interested in what's going on there and so on, please have a look. Maybe figure out in your company who's the contact for the W3C and ask him whether there was already some feedback. If you have a point, maybe make him aware that there will be an AC review and that it might be a good idea to support this work. Pretty soon, on the 27th of July, we want to have the resolution within the interest group that we are happy with the draft charter that we have, and then send it to W3C management and basically start the AC review. So there's a period that the text that the management basically approves. It will have some additions, and then on August 24th, we want to start this so-called AC review. So that's the advisory committee of the W3C. It's basically built up of representatives per member company. And so this is then a longer process. And so for this, we want to be prepared. So again, if you already have some feedback, please give it to us so we are in very good shape. Because the overall goal is to have the working group running in about October this year. And for that, we want to minimize the changes that we have to include after the review. Again, here's the UI. You can share your feedback either directly, or the transparent way would be the mailing list, or even better, the GitHub issues we have for this document. So a quick update on basically what we have been working on lately, so where we had the main progress. So one thing is we saw that we will need some kind of type system in our thing description. So maybe to step back a bit, so a major building block within this Web of Things architecture is the thing description. It's supposed to be a machine understandable format to describe the data and interaction model of a thing. And for this, we also need some kind of new type system that is not as closely coupled as existing ones, like, for instance, XML schema. We have the problem that we really define on a bit level what kind of data point this is. But in the web, we saw that things like JSON are actually much better, because it's then up to the implementation how to handle this. The important part is this a number? Is this a string? Is it maybe a enumeration, and so on? And so we started to look at different things that are popular at the moment in the web. And well, for now, we picked something that was popular with a few people that fulfilled the basic requirements. But this, again, is not kind of a choice that we make. It's just now to run experiments to figure out what we actually need. One of the central things are basically that we can have these semantic annotations directly alongside the definition of the structure. And I sometimes try to describe this as something, at the moment we have documents that describe representation formats. So what is identified by the internet media types. We have a textual description of the information model that is behind that. So that means you need a human being to read that, and then to implement that correctly, to have the parsers, the generators, and so on. It would be very good if we would have something that is actually machine understandable, so that we can define how the structure of these representation formats look like, and then also annotate directly, like, what element within there, what is the meaning behind that, and how does it link to the larger concepts. And because this is quite a huge can of worms, it would be nice to have already tool support with that, so that not everything has to be created from scratch, but take something that's already out there. And this is also, again, kind of a call for action. If you are working on topics like this, like type systems and so on, and know some nice technology that is maybe not called schema, but something else. There was the hint, for instance, for RelaxNG, which does also this job. Please join the interest group, and maybe just contribute what you know, so that we actually know what is out there and what might be the best candidate. The other part is the scripting API. So normally how IoT devices look like, they have some kind of stack, and the application logic is directly written in the native language, so C or C++, or whatever you have. And another building block that we want to provide is a runtime environment that is kind of similar to what we already have with the web browsers. So there we can deploy these scripted applications on different platforms. It's quite portable and flexible. And the idea is to have something similar for the Internet of Things. So that means that we have something like a faceless runtime environment similar to the web browser, but for the automation that is going on the devices directly. So we heard, for instance, something about this JavaScript, so a compact JavaScript interpreter that can run that. We are not focusing on JavaScript alone. There's also Lua, for instance, quite popular in industry to script these kind of behaviors. And within the working group, we actually want to define a standard API so that we can have something like portable applications that can be moved from one device to another device, or maybe some local hub that has more processing power, or even up to the cloud, if that would be the better point and fulfills the quality of service requirements and so on. So we have been working a lot on this. And, sorry, that's the nice animation that illustrates how this should work. I hope this is clear now. We have been working on this and now have the first running prototypes that implement the API that we are defining. So what we need is basically the server kind of API where we can define, okay, this thing should expose these interactions. and attach some kind of callbacks to that. I won't go through this code. It just shows, okay, we have some scripted behavior that brands this device or tells the device how it should behave. And then we have this client API to really script the web mashups. So basically the idea of web mashups on a thing-to-thing basis, so that there's one thing, we give it a script, and then can interact with the surrounding things, or in general, actually all the things it can reach and discover. And so a lot of this is actually brand new. So because just a week before the IETF, there was the face-to-face meeting of the Web of Things interest group in Beijing. And the event itself, it was hosted by a Chinese company called CTC. So it's kind of a government company that is working on Internet of Things standards. And they were so nice to host the event. It was co-located with one of their own events, which had the advantage that, yeah, we could get in touch with them, see what's going on in China about this, and then also get in contact with some local companies that were also interested basically in this work. So it's, yeah, was kind of the networking aspect. But we also got our agenda done. So one important part is the Plugfest, as I said. So different companies come together and check their implementations, if they already can work together, and if the drafts of the technical specifications, well, as I said, the interest group cannot actually do specifications. However, we already draft how this could work, and these working assumptions we confirm with running code in these Plugfests. And then we had, yeah, I have a lot of typos unfortunately in here. Yeah, a plenary discussion and some breakouts about specific topics. For that, I want to refer to the material we have on the W3C websites. To give you an idea how this looks like, so we had different scenarios based on the capabilities that were implemented. So one thing was, for instance, that we can have a generic web UI that can read a thing description and then can render a user interface to interact with such a device. We have some embedded controllers that can host these scripts. So we had this scripting API I was talking about on this industrial controller. And we were able to then connect to some actual things that were provided by a different company. And so far, this worked out as planned. We also had a more complex scenario where a nice part is Fujitsu, for instance, they extended a web browser with this Web of Things API. So we could deliver basically a script like a web page. Actually, it was a web page that combines a user interface and then the interaction with other things to this web browser, and that then could figure out how to work with this thing. We had a small embedded device that was able to do a lookup for a specific device where it could do some voting. So this is based on semantic lookup actually, and yeah, through this mashup, then control an air condition that was by yet another company. And there were also some experimentation about rule-based automation. So this is then a different experiment. So we do not use scripting, where you have kind of define it yeah, using a scripting language, but a rule-based engine that uses these semantic statements to define, yeah, if this occurs, that should happen. So the usual rule-based automation. That's it. We also have some material if you're further interested what happened there. There are minutes. We also have defined some test cases, for instance, and are currently working on the report on that. So kind of what features that we imagined were covered in this Plugfest, and yeah, get an overview what is already implemented and how did it work, what was already interoperable and so on. That should be it. Yeah, thank you. A question would be, is there interest in this room to work together with the W3C in this part? As I said, so this is maybe a special setup because we are in close contact with the IETF in this way. So we have these joint meetings together with the Think2Think research group, and it kind of is the idea to make sure that the protocols and specifications that are developed within the IETF kind of are used as they are thought to be used on the higher levels, which means then, yeah, in the space of the web and W3C, let's say. Is there any feedback on that, ideas?
Christian Groves. I think at the last meeting there was some talk of having a joint meeting with W3C in September.
Yeah.
Is that still going, or because I didn't see it on the earlier slides about?
So this is planned. I don't know actually whether you have the announcement later. I can do it right now. So the TPAC is in September this year in Lisbon, and on the 24th and 25th, so that's on the weekend after this TPAC meeting of W3C, we will have the joint meeting between this group and the Web of Things interest group.
In Lisbon, yep.
In Lisbon, yeah. Okay.
Okay, if no more questions on that, we have now a slot to, for a quick sales update and roadmaps for the documents that are currently being discussed at the research group. And as Carsten mentioned, one of the documents that is currently active here is this RESTful design for Internet of Things systems. So the goal of this particular draft is to give guidance when you are designing for an IoT system that is supposed to be following this REST architectural style. And where the document currently is basically a collection of some basic guidance on what we have found useful and where we have found some perhaps other SDOs or perhaps some other designers struggling on some of the basic concepts of RESTful design. And also it's a collection of basic terminology, so we have a common vocabulary we can be using when talking about these things. What's our current idea with this draft is that it has already sort of useful information, but there are a couple of key things that have been requested from us that we should be discussing there. In particular, application state. Currently, as in traditional REST, as it has been defined, application state is in the client side. Then there are a bit of more discussion that what is that the full picture today, what is the role of the resources in the full application state, etc. So trying to clarify that and trying to have a common view on what is really the application state in the RESTful systems today. We are planning to add some information on discovery mechanisms. So that's something that is currently apparently not that well known outside of these circles. So for example, you can use the not well known. You can use things as resource directories for discovering things and how to use those as part of your full IoT system. Then we are planning to add some information on resource design guidance. So when you go about designing your RESTful APIs and your RESTful application, what should you choose as a resource? What are the media types you should be using and how to choose them and so forth. Basically getting people started on that. And finally, there's this hypermedia driven applications that are very much looked in the research group currently, and it's an active research area. So we are thinking of having an introduction to that, but not really going in much into details, because that is still an area where we are looking into what are the right solutions, what works, what doesn't, in the context of IoT. So the idea would be have an introductory text there and pointing to the documents that are discussing more of the details. And we had a quite lengthy discussion on this a few days ago with co-authors, and like, where do we want to take this document? Is this the kind of style we want to do it, or is something we want to actually push much further? And we figured out maybe the best way approach is that it's already quite a lot of useful information that would be good to be able to disseminate on a wider scope. So in that sense, it would be good to publish document roughly in this form with the information that is also added there. And then the whole hypermedia aspects would be then discussed in the future documents. So that's where we are right now. So of course, encourage you to all read the draft and let us know if there are something particular issues you have been struggling, or maybe your colleagues have been struggling, or other SDOs where it could be contributed here.
So quick check, who has read a version of this document? Is the draft in here somewhere? Yeah. Okay, only the front row has read the document. Interesting. And who would be willing to provide a review when we finish this? Michael just nods. Hannes, very good. Thank you. Next, Oscar. Is Oscar here? Yes.
Okay, thank you. So this is about security. Yeah, thank you. That's also very useful. About the internet draft that we wrote a few years ago and how to move forward with it. So that's an overview of that internet draft. I think it's from 2011, more or less. So there we started thinking about the thing life cycle. We had some architectural considerations. We also put the state of the art at that point of time that was quite different. And then we put a bunch of challenges, mainly related to the constraints of the devices, to the bootstrapping and the operation. Then we finished with a number of security profiles, thinking about if you have a home environment or industrial environment, if you are connected to the internet or not. So discussions with autos and looking at the things that have happened during the last year. So the proposed way forward is basically, well, the thing life cycle is what we had, and that was the figure that Carsten was presenting before, more or less.
Great.
For the architectural considerations, then we have to update, the same for the state of the art, because lots of things happen. And for the challenges, well, constraints remain the same. Bootstrapping, there is a new bootstrapping draft, so the idea will be to be referring to that one. Operation should be updated, and also there is a bunch of new challenges, for instance, the one related to software updates and others that are described later. And what we will also propose is to include a new section with solutions that either that are already existing, and the security profiles will be also updated accordingly. And here are a few overview of research topics that come from recent events. So firmware updates, transparency and attestation of the communications, avoid device fingerprinting, and others. And here you have even more, for instance, forensic readiness or regulations and compliance, or topics related to long-term security. So, for instance, if you have to sign a software update, which signature algorithm are you going to use for that? If that signature needs to be valid in 20 years from now. And we also made a proposal related to how to move with the draft. So I was not active during last time, but I mean, I will come, and basically Sandeep and I will be taking the part related to architectural considerations and the state of the art, and then we discuss with Mohit that then he could take the other parts and also leave the other part. And that is questions, answers, otherwise. Questions? Otherwise, later you can talk to me or Mohit, who's over there.
Thank you. So the one microphone is enough. So the idea is that this document can be referenced from other documents that are in the IoT space, so they don't have to repeat everything in every security considerations section of every document. I still have another slide about this document. Who provided that? Oh dear. Yeah. So the next one is the bootstrapping survey.
This is our draft, basically surveying the different bootstrapping mechanisms that are available for IoT. And I won't be going through everything that is covered in the draft, but just the updates since the last IETF. So last IETF we had a long discussion about identity and identifiers and what is secure bootstrapping. So based on the feedback that I got, I have updated the draft. I hope you can read and provide some comments on the list. Also, instead of adding yet another definition of bootstrapping, I just covered the goals of bootstrapping and I have covered what is onboarding and how does OIC or OCF define bootstrapping and distinguishes between bootstrapping and onboarding. The draft that was published last time was not updated with the categorization, so we have the same 4 classes. There's the managed methods. It was missing some text on Anima, so now we have at least 1 paragraph on Anima bootstrapping. Then we have the peer-to-peer and ad hoc methods, and I updated some examples there. And we have the opportunistic or leap of faith methods. I added 1 example there that I think, Carsten, you had presented in the workshop in Paris in 2012. Also, I would like to state that I don't add all the examples there, only what are relevant for IoT. So of course, if your device is big enough and can use SEND, CGA, or TLS, DTLS, or other forms, I mean, you are more than free to use them. This draft just focuses on solutions that are out there or are being proposed and which are focused on IoT. We have hybrid methods. I haven't changed anything here in this version. And so the next steps, I think, couple of points. Is there some hidden gems or best practices, and some text on ownership transfer and how does that affect bootstrapping, I think is important. But other than that, I think the draft is more or less ready, and it would be good to receive feedback here or on the list.
So do we have review from the people who have created those various bootstrap techniques? Do we have an idea how to get them to look at this?
Hi, Elliot Lear again. I did review this document, and it's a nice survey, if you will. As it happens, as broad as it is, as many mechanisms as you found, there are more. So the Wi-Fi Alliance is working on one called DPP. Which
Device Provisioning Protocol. But I think the point is not to cover all the 100, but just to categorize them. And if I, as an IoT developer or solution deployer, like if I read this 10 maximum 15-page document, I should get an idea of what options I have and what are the pros and cons and trade-offs. If I go out there and list all the 100, I think I would be old or probably dead by then.
Okay, so then we're going to have to get into a nice, healthy discussion as to how to recommend which ones to choose and when.
Sure. So please send feedback on the list.
Good. Cool. Who wants to do this? Michael, Klaus?
So Klaus Harke and I are working on some very similar areas to enable hypermedia for machine interaction. And we're each working on a somewhat different thing, but we found that there are really a lot of similarities. Both we're attempting to represent collections, which consist of links, hyperlinks, and items that the hyperlinks describe and point to. We're trying to build a system for forms that describe resource state updates, similar to the way HTML forms work, but specialized for this sort of thing. And we find that the data models that we chose are more or less interoperable between the Klaus's work and between Coral and HSML. But there's some important differences also. Maybe the first one isn't so important, but the Coral data model is derived from HAL, Hypermedia Application Layer, which can be found as another internet draft. And HSML uses core link format and CNML, core link format for links and CNML for items. And as I said, they're more or less interoperable. Coral uses media types to define application semantic vocabularies. And this is probably the fundamental difference, that with Coral, the media type defines the vocabulary and the serialization. And with HSML, the idea is to use consistent serialization and use link annotation to embed the application semantics, so it would be external semantics. Going forward, what we want to do is create a common use case prototype so we can evaluate these two, and find out what the differences really are, significant differences to an application writer or a developer. So we'll evaluate cross-domain interoperability. So how does a thing from one domain interact with a thing from a different domain where you actually need some semantic discovery and some alignment there? How does the difference in the way semantic application annotation is done impact the application design? Is either of those easier or harder to work with? And then how is it for discovery, resource construction, and application interaction? Is there any significant differences there? And the goal is to converge to one representation format and interaction model. Since they're so similar, we really only need one. Thank you. Good.
Okay, so where's the documents and topics discussed so far have been already on the research group agenda for some time. This is actually a brand new draft that was submitted to the RG and the data tracker right before the deadline. So it's about Bluetooth low energy URI schema and media types. So for a quick background, probably many of you or even all of you know, Bluetooth low energy is pretty popular not only in your smartphones, but also on the constraint space as a very efficient technology for communication. And the resources on a Bluetooth device can be accessed in various different ways. There is already a definition for running IP over Bluetooth, so you can use your usual co-op, etc. protocols there. There's from Bluetooth SIG, there's a gateway specifications. You can use a gateway to access the resources. However, these are all interaction over a network. So how about if the Bluetooth device is connected locally? So you are actually running, for example, code on the device where you are communicating or maybe accessing via proxy. And how do you can use web technologies to communicate with such a device? So what this draft is a strawman proposal for a URI scheme and a media types that can be used in this kind of context. So just give you an quick example, how does it looks like, what are we defining in the draft, is that, for example, you have, if you want to do get a list of nodes that are connected to you, you can do a get to this particular URI. The result would be a set of links that both point to sort of nodes which have services there, and you can then furthermore query this URI and get, for example, a list of service identifiers in this media type of application DL get service list. So that's just one example. Here's the CDDL of what kind of that structure could look like. So this is one example of how this kind of mechanism could be used in a bigger picture using Bluetooth devices in a web context. So next steps, as I mentioned, this is just a strawman proposal. It's pretty short, just gives you an idea what this could look like. So of course we need to be adding much more details if we think this is the right way to go. And also we recently learned about this web Bluetooth work that seems to be very relevant. So aligning between those two, of course, makes a lot of sense. And then of course, reuse from Bluetooth experts. Karsten and I, who are the co-authors, are not Bluetooth experts, but we kind of have some idea of the web IoT context, so we decided to write this draft. We are already in contact with some of the people in Bluetooth, so I got some initial comments, but getting more of that. But then also getting more reviews from all of you. Do you think this kind of thing would be useful? Is this the right direction to go? Is this something completely different needed? That would be very helpful feedback. Yeah, unfortunately not today since we're very limited on time, but please join the discussion on the mailing list. Then, do we have, yes.
Yeah, we have about 90 seconds left in the agenda item.
Okay, so I will be very fast. So this is talking about the IoT service platform and the data module. Here I show one picture of the smart home ecosystem. So there is 4 entities involved here. We have a device in the user's home, which can connect to the IoT service platform. The users can also have applications on their mobile phone to locally control the, for example, the home appliance devices, or they can remotely control from the service platform cloud. So actually, in this ecosystem, there are many standards is needed. For example, how the application can control different home appliance devices from different vendors, and how different home appliance devices to connect to the IoT service platform, and how the platform could be interoperate. So this draft propose a data model to solve this problem. I will skip the detail of just to show one concrete example how the message is could work. This is one example that the device posts the data to the IoT service platform. Here we have a system section. So those parameters used to authenticate the messages, and we have a request section that those parameters used to identify the device, and also to identify the response, the corresponding response message. And also we have a method section that defines the action of the, what kind of action of this message. And also we have other detailed parameters. So the idea is to define some profile about the home automation scenario. So if anyone interested in this work, please send comments to the mailing list or can talk to me offline. Thank you.
Thank you. Okay, now for something completely different. As I already said, we are going to have a meeting about distributed infrastructure in 1 hour from now. Maybe as a little taster for that, we will have a short talk by Tibor Pardi about secure, decentralized, blockchain-based Internet of Things. So this is maybe not something we are going to deploy tomorrow everywhere, but maybe something that we use for thinking about. So Tibor, you need to request speaker rights so we can press the red button and get you.
Yeah, hi, Carsten, thanks very much. And could you please put the first slide?
Wait a minute.
Yeah, and I turned off my camera, and it's a bit echoing.
Should be on.
Yeah, that's fine. Yeah, but I can hear a bit echoing, but it's fine. It should be okay. So, and just please let me explain that we have a hottest day in the UK, in the United Kingdom. It's 33 degrees today, and I put that fan to my room, and it just making a power outage in my place. So twice already. That's why I went offline 5 minutes ago. We had a power outage. So if I am off, then I will be back. So, but thanks very much for having me. And so thanks for this opportunity to talk about the decentralized peer-to-peer IoT. And could you please put the first slide? And to introduce myself, my name is Tibor Zsortpaladi. I am an open source developer, and I work with a group of open source developers to implement blockchain-based decentralized peer-to-peer applications. And not long time ago, we released such application, which is Streambit. And you can find on the streambit.github.io more information about it. You can find the blogs and technical information. Also, Streambit members like myself and others try to participate in the W3C VOT standardization process. We try to focus on security as much time as we have, and also try to advocate and spread the word about decentralized blockchain-based IoT technologies. And if you could put the next slide, please.
Yes.
Yeah, thanks very much. So I will try to give an overview from the software engineering standpoint, because myself, I am a software engineer. However, first, probably everyone would ask, why would we need to bother with that blockchain technology? Why would existing client-server infrastructure, which already companies invested billions of dollars in, and cloud infrastructure, which is very much matured and very fine infrastructure, why would we would need to throw away just because this new blockchain technology came? And so just the first point, we don't suggest that the existing client-server infrastructure should be thrown away, because blockchain technology could be complementary and could fit well into client-server topology. I wrote a blog on that website, which I quoted in the weekend. There is a blog which tried to explain how actually client-server infrastructure and blockchain can work together. However, we think that even the client-server infrastructure and the cloud solutions are great. We think there are a few problems which actually blockchain and decentralized computing could address. For example, the biggest problem in our view, the privacy, because a centralized system which has a server relay the data from device to human users, so they have the metadata and everything. So from privacy standpoint, we believe the peer-to-peer blockchain solutions are one of a possible solution, and which mitigates the privacy issue which we have with client-server infrastructure. Because how we see that if we have a garage door controller or a front door controller for your house, we think that it's not the government business, not the third-party solution provider business when we open that garage door, when we go home, or if we have a CCTV camera which IoT connected. We think that it's not the surveillance task to monitor that. So we believe that blockchain-based peer-to-peer solution can solve that problem. Because by definition, we manage the communication end-to-end encrypted peer-to-peer. Also, there is a security risk, we think, because most of the centralized client-server solutions are a convenient target for cyber criminals, industrial spies, as well as most of statistic indicates that many of these attacks actually use inside. It's an inside job, so it's used employees, and by definition a blockchain which does not involve a solution provider, we don't have such employee in that sense in the ecosystem, so there is a security risk can be solved by the blockchain. The biggest unique selling point for blockchain, in my opinion, the economy aspect of the offering, because if you think about it, scalability and high availability, it's a big business problem. It's a very expensive proposition to address scalability and high availability. If your business is successful, you will need more and more server to have a high availability to guaranteed across geographical locations. You would need the different data centers. By definition, decentralized technology and blockchain solve that problem, because a blockchain or a decentralized network, a distributed hash table-based network, is the composite of nodes, so it's theoretically infinitely scalable, and we believe that blockchain and decentralized technology could save a very big amount of money for businesses by implementing that scalability and high availability. Other aspect of that, which we think maybe blockchain will be applicable and decentralized computing will be applicable, some political aspects, because there are already laws and legislations which require solution providers surrender the cryptographic keys. And by definition, the blockchain don't have any solution provider, because it's the composite of individual nodes. So there is nothing to surrender. There are court orders already which says that individual users or citizens, they don't have to surrender cryptographic key. So if you could please go to the next slide. So I was trying to explain what was the problem and why we see the blockchain could be applicable. And so the solution, we believe that a decentralized peer-to-peer system, we don't say that it's suitable for all IoT use cases. However, we say that certain use case, for example, the garage door controller or what I mentioned, which a user using the mobile phone and open and close the garage door, we believe that is absolutely not necessary to have a central server component for that use case. So the blockchain can do a lot for us. For example, that it can confirm the data origin. Using the blockchain and cryptography methods and functions, we can ensure data accuracy, as well as it could be very useful because everything in the blockchain, it actually could be used for auditing, and auditing is always a big business problem. So for auditing it could be useful as well. And the blockchain theoretically it's can handle a very large amount of data. So again, for data storage reason, it's a quite appealing solution in our opinion. The last element of this, that smart contracts, you probably heard a lot lately about smart contracts. Most of the news was negative when people lost money with Ethereum and those kind of things. But however, smart contract could be a useful technology in Internet of Things as well. Smart contract, when we say smart contract, it is a computing entity which requires a Turing complete computer language, which different solutions, different blockchains use different language, but we think the JavaScript is just perfectly fine for that. And to just give you a practical sample, what smart contract could be. Currently, we have a military defense sector use case. And we implement a self-destructing message based on smart contract. What it does, we have a drone, a military drone, and if it goes over any enemy territories, then we have the GPS data. We program the smart contract to say that if the device is not moving, and if it's over enemy territories and it's not moving anymore, then destroy all messages in the devices. So it just try to indicate the power of this smart contract, which again is based on the Turing complete programming language. So if we could go to the next slide, please. As I am sure, as you know, when you work with Internet of Things, that device discovery is a big problem, and it's a huge business, huge technological challenge for Internet of Things system. And we believe that a distributed hash table or blockchain, when I am referring to blockchain, it could be either a Merkle tree, like a Bitcoin blockchain is a Merkle tree, or it could be a distributed hash table. And we believe that this topology, when we don't have a central entity, however, we have the distributed storage, could be very useful to facilitate the connection between human and devices. Because, yeah, the human has to know that the DHCP IP address setup device, what was the IP address of that. And instead of using DNS servers and all those centralized solutions, we use the distributed hash table for that, to share that information between human and devices. And please note, I just want to emphasize that we don't suggest anything radically new, because the distributed hash table, for example, it's already revolutionized the music and film industry. So as you know, in the last 15 years, people completely changed how the music and film is consumed. And so that very same distributed hash table, which drives the BitTorrent network, we can use for Internet of Things devices. So I am not suggesting we are using the network what BitTorrent is. What I am saying that the distributed hash table is pretty much the same, technology-wise and conceptually. And if we go to the next slide, please, and maybe one further, please. If we can just to go to the next slide, maybe the picture on the, this one. So other area which peer-to-peer decentralized system can handle itself the device handling, because at the beginning I mentioned to you the garage door controller use case. So having this ecosystem with the distributed hash table blockchain and the peer-to-peer, mainly the peer-to-peer communication, the important in that sense, we can handle those devices without going through on a central server. And again, as in the first slide, we discussed that what are the security, political, and economical problem with the central solution. By taking out from the ecosystem the central solution, the device can be controlled by the human in a peer-to-peer manner. And the beauty of that we can do that in a completely end-to-end encrypted manner. So we can do it securely, and it's the current picture shows you a stream bit, but it's not exclusive to our system, which is again a very new system, and there are a lot of or a few other decentralized systems which exactly handles exactly in the same manner this peer-to-peer communication and end-to-end encryption. If we go to the next slide, please, and the other area could be could be very important for Internet of Things applications, the device upgrade and the device provisioning and device management. In terms of, when I say device management is configuring the device, it's always a challenge for hardware manufacturers or solution providers how to upgrade the device. And if you can go to the next slide, please. So the blockchain and the distributed hash table can use for device upgrade as well, because what we suggest in here, asynchronous and event-driven system, when loosely coupled components, they're not very whether the other component is alive. So what's happening workflow-wise? The IoT hardware manufacturer published the device upgrade to the blockchain or to the distributed hash table, and once it's published in encrypted form, the device manufacturer not concerned whether the device is alive and what's the status of the device. Once the device is alive and connected to the network, we'll get from that distributed storage, which is a blockchain or the DHT, the device upgrade. So with very low cost, very economically, and quite elegantly and securely, we can manage that use case like device upgrade, as well as the same way we can push all kind of information to the device. And again, it's a event-driven and asynchronous method architecture. So if we go to the next slide, please. And all we discussed so far, it's very much connected with the security, and we think that the whole blockchain and decentralized the IoT proposition is could be very important because it actually does what it does securely. So you know, the security handled by definition by the blockchain using a public-private key cryptography. Most of the blockchain and decentralized solution use ECC, elliptic cryptography, and as I said, is end-to-end encrypted with the 256-bit asymmetric key. And we use, as the slide shows, we are using generic cryptographic methods, so we are not inventing anything new. We're just using standard-based implementation. So if we can go to the next slide, please. I would explain that we try to work on standards as well. We have no experience in standardization. We are software engineers, but we want to create an IETF standard which defines this decentralized IoT, peer-to-peer IoT system. And we have a GitHub repository. So if you could help us, please, we can work together maybe to create a standard which govern the whole decentralized peer-to-peer IoT works. And on the last slide, if you could go there, please, you will see my details. Please contact me anytime on email or Skype or any channel. If you have any questions, I will be happy to reply in email or Skype, have a conversation about it. And thanks very much for listening. And if you have questions, let me know and try to answer.
Hi, this is Lars Eggert. I have a question. It's probably a stupid one, but I'm going to ask it anyway. So you talk a lot about decentralized peer-to-peer, but in the slides you showed, all the arrows pointed at that Streambit thing in the middle. That looks mightily centralized to me.
Well, it's maybe on the picture. Thanks very much for your question. And in the picture, maybe it looks very centralized, but it's probably my fault how I present it. But you know what you see on the picture and Streambit on the middle. And again, this is my application, and there are others, so I just put my application there. That middle component, it's actually the big blockchain. What you can see, or the big DHT. So the distributed hash table, what you see, so that central rectangle, that's a blockchain or a distributed hash table, which is a composite of 1,000, 100,000, or 1 million nodes. At the moment, you know, if we would try to model on a picture, the Bitcoin blockchain, you would see the very same. You would see users around that central rectangle, and you would see in the middle that a Bitcoin blockchain. But the Bitcoin blockchain is actually distributed. So probably that picture don't give in this case, if you say it's not understandable, probably not the good picture. But what I am trying to say that central rectangle, yeah, it's a composite of many nodes. Yeah.
So if I understand you correctly, the DHT actually runs on the end systems that are shown on the top and on the bottom.
That's correct. That's correct.
Okay.
That's correct.
So is peer-to-peer really the best communication approach for IoT, given the resource constraints that we have, and given that you might forward traffic that is, not for you, and you might be becoming a super node in the DHT and get a lot of traffic?
Well, it's a very good question, and what we say then W3C as well, and what we say when this question come up, that I think, or at least what I came across, most of the Internet of Things use cases always have a gateway component. So it's very rare that a light switch would be able to communicate with the cloud or whatever. So once we have a gateway component like Raspberry Pi or Raspberry Pi just in reference design, but once we have a gateway component, that gateway component is perfectly capable to run that bloated infrastructure, which you very correctly point out that is a quite big infrastructure. So we don't say that the very low constraint device can run this. It's not possible. You're absolutely right. However, the gateway can run that infrastructure.
So then you delegate the trust, right? Because everybody who participates in the blockchain needs to have a copy of the blockchain in order to issue transactions against it.
Well, if you run Bitcoin blockchain, yes. But if anyone asks us, and that's why you never see in that presentation Bitcoin blockchain that it's a bloated and you have to have. But if we use distributed hash table, it's a bit different the scenario. And I wrote a white paper for that. So on that website, which I presented the link, you can see the white paper, and I try to explain how it works. But yeah, that's a valid question. That in a Bitcoin blockchain, that's the case. However, we would never advise to anyone to try to use the Bitcoin blockchain for IoT devices, because it's just simply not possible for many reasons, for the block time and all those things. We say the distributed hash table are the best solution for that.
Hi, Juan Perez. What's your thinking around the maintenance of the blockchain itself, and in terms of the economics of maintaining the blockchain and being able to use it?
Well, I think, terms of maintenance, it's partly it's a political issue, as you can see with the Bitcoin blockchain right now, that there are disagreements. So which direction it goes is partly has a political elements. But apart from this, my understanding is, and we think that the maintenance, if we talk about maintenance as running, that is a very low cost maintenance because the peers run the ecosystem. So that's why we say it can save money for organization, the blockchain and the distributed hash table type of concept, because the cost is disseminated or spread to the nodes.
So do you have a very quick question?
Yeah, Jérôme, just a remark about the previous comment about performance issues with super peers or something like that. We already had a lot of experience using peer-to-peer and IoT for building automation, and we were able to distribute also machine learning in a peer-to-peer way, and we can totally rely on gateways that we have on every floor of buildings, and we were successful deploying that.
Can you repeat your name?
Jérôme Beauvais.
Thank you.
If I can echo this, we have the exactly same experience, and we got question how it's possible to manage that with peer-to-peer, but please, if you think about it, for example, in a CCTV camera IoT use case or any other IoT use case, for my understanding is if we don't have a central relay component which relays the communication, but we do it peer-to-peer, by definition, it must be the best possible quality and best possible speed as we could have. So if you think about it, if we don't relay that data through a server component, but we relay between the peer communicates directly, if we take out from the ecosystem that central component, obviously the communication must be quicker than if we have a central component.
Okay, I think we need to finish at this point in time. Thank you, Tibor, for this presentation. We have one item left on the list.
Okay, thanks.
Quick discussion of the future activities. And as was already mentioned, the W3C is going to have a TPAC meeting, which is their annual big event in Lisbon in the week from September 19th to September 23rd. The Web of Things group will meet on Thursday, Friday that week. And we are going to run a meeting on Saturday, Sunday to continue the discussion. And we are also going to join in on the W3C work on Thursday, Friday. So this is a meeting that is pretty much defined. There's also a meeting coming up in October, in the week from the, what is it, 23rd something, co-located with EclipseCon in Germany. So that's a big open source event, and that might give us some more opportunity to talk to open source people. We are looking at doing something around the Seoul IETF meeting. And in particular, if you are from the area, and in particular if you're from Korea and are interested in doing something, maybe at the weekend before the IETF, or maybe something different, just talk to us. We would like to set up something there. Finally, there is something, a very, very raw idea at this moment. In February, there is the EWSN conference in Sweden, and we are looking at maybe co-locating a workshop there. This would not be an ACM-sponsored workshop as an EWSN workshop, but it would just be a workshop that uses the location and the support from the organizers to bring people together that fit to the EWSN profile. And the subject that has been coming up there is what do various networks that run within a single premise or within a single environment possibly need to share to do this successfully. So this is a coexistence issue, but maybe less about the typical spectrum coexistence, but more about exchanging information between administratively not connected systems. So if you have any other idea of what the research group should be doing, where it should be meeting, please contact us. Otherwise, see you in September in Lisbon.
Lars, I have one sort of plea, and this is not only to you guys. Putting stuff on a Saturday and Sunday for IETFs makes it impossible for people to attend if you have, other things to do on those days, which many people do. So doing this regularly, I mean, NFV does it regularly, ICN is doing it, so it's kind of difficult to attend these things if you all collide. I don't know a good solution, but
the solution is probably going to be Friday, Saturday.
Or maybe the solution is we only pick one research group that gets a Saturday, Sunday.
Okay, and then also one more comment on the Seoul meeting. What we have been discussing, we haven't had actually a working meeting as such for quite some time. It's been only summary meetings with the IETF. So one thing we are considering to have a bit more time to actually discuss the drafts and have some good face-to-face time. If you think that's useful, please let us know that that's something what we are considering right now. Okay, I see a few thumbs up and nodding. And then also blue sheets, if you didn't sign yet, please do sign. Where are the blue sheets?
Have a good social.
Okay.
In